discuss the continuity of the function at x equal to 0, and the function is given fx is equal to e to the power 1 by x minus 1 divided by e to the power 1 by x plus 1 when x is not equal to 0, and the function fx is equal to 1 when x is equal to 0, and we have to test the continuity of the function at x equal to 0. To test the continuity of a function in terms of limit, we have to follow these following steps. Number 1, fx has to be defined at x equal to c, and number 2, limit of fx x approaches to c is equal to fc, or left hand limit is equal to right hand limit. So first check that the function fx, whether it is defined at x equal to 0 or not, because it is given to test or find out the continuity of the function at x equal to 0. So first we will find out what will be f0. Fx is equal to e to the power 1 by x minus 1 divided by e to the power 1 by x plus 1, and it is given when x equal to 0 it is equal to 1. So f0 is equal to 1. That is why the function has to be defined at x equal to 0. Then what is the next step? The next step is we have to find out the left hand limit and the right hand limit, and if the left hand limit will be equal to the right hand limit and that is equal to fc, then we can say that the function is continuous at x equal to 0, otherwise it is discontinuous. So now let us check the left hand limit of the function. What will be the left hand limit? You see, the left hand limit of the function fx is given by x approaches to limit of fx x approaches to 0 minus. Left hand to 0 is 0 minus. So the given function is limit e to the power 1 by x minus 1 divided by e to the power 1 by x plus 1 when x approaches to 0 minus. And when x approaches to 0 minus, the value of x is slightly less than 0. That means you can put the value of x 0 minus h, where h is a very small value. So in this expression of the function, you put x is equal to 0 minus h. So the function will be e to the power 1 divided by 0 minus h minus 1 divided by e to the power 1 by 0 minus h plus 1, and h approaches to 0. So that will be equal to limit e to the power 1 by minus h, because 0 minus h, this is equal to minus h minus 1 divided by e to the power 1 by minus h, because here also 1 divided by 0 minus h is equal to minus h. So e to the power 1 by minus h plus 1, h approaches to 0. And the numerator will be equal to, you see, e to the power, if you put 0, h is equal to 0, 1 by 0 is equal to infinite, and minus is here. So this will be equal to e to the power minus infinite minus 1, and here in the denominator if you put h is equal to 0, this will be equal to e to the power minus infinite plus 1. So in the denominator e to the power minus infinite plus 1. So now you e to the power minus infinite, you can write 1 divided by e to the power infinite minus 1, and e to the power minus infinite, here also you can write 1 divided by e to the power infinite plus 1, and e to the power infinite is equal to infinite, and 1 by infinite is equal to 0. So in the numerator you have 0 minus 1, and in the denominator you have 0 plus 1. So minus 1 divided by plus 1, this will be equal to minus 1. But f0 we have found out this is equal to 1, but here the left hand limit is equal to minus 1. So the left hand limit is not equal to fc. Similarly, if you check the right hand limit is also not equal to fc or not equal to the left hand limit, then the function is discontinuous at x equal to 0. So now find out the right hand limit. For the right hand limit, you see, the right hand limit of fx as x approaches to 0 plus, we have to find out the continuity of the function. Check the continuity of the function at x equal to 0 to the right of 0, that is why x approaches to 0 plus. So this will be equal to limit, the function is given e to the power 1 by x minus 1 divided by e to the power 1 by x plus 1 and x approaches to 0 plus. Since x approaches to 0 plus, we take a value of 0 slightly greater than 0. So you can substitute x value is equal to 0 plus h. So this function will be equal to e to the power 1 divided by 0 plus h minus 1 divided by e to the power 1 by 0 plus h plus 1. So e to the power 1 by 0 plus h plus 1. And this will be equal to, in the numerator you have e to the power 1 by 0 plus h means e to the power 1 by h minus 1 divided by, in the denominator you have 1 by 0 plus h, that is equal to h. So e to the power 1 by h plus 1 and e to the power, you see 1 by 0. 1 by 0 is equal to infinite. So this will be equal to e to the power infinite minus 1 and in the denominator e to the power 1 by 0 is equal to also infinite. So it will be equal to e to the power infinite plus 1. And if you divide e to the power infinite in the numerator as well as in the denominator, e to the power infinite divided by e to the power infinite, that will be equal to 1 and 1 divided by e to the power infinite. Again in the denominator also e to the power infinite divided by e to the power infinite is equal to 1 and the second term is 1 by e to the power infinite. And 1 by e to the power infinite is equal to 0. So in the numerator you have 1 and in the denominator also 1 divided by 1, that is equal to 1. So you see the left hand limit minus 1 and right hand limit plus 1. So left hand limit is not equal to the right hand limit. That is why the function is discontinuous at x equal to 0. Thank you.